with the second wrapping functions video, wrapping 2. In this example, in this video actually, I'll just take you through this example and that'll be it. So once again, as stated in wrapping functions 1, the starting point of every wrap that we do will be the right hand side of the object where it meets the positive x-axis. So our starting point here in this particular problem is going to be at 7, 0. So a wrap of 0 would leave us at 7, 0. The positive direction will always be this counterclockwise direction, going around the figure that way. So to do a wrap of 1, we'd have to start at 7, 0 and move up along this route, which would be the point 7, 1. A wrap of 2 brings us up here, this is 1, and then over this way for 2, 6, 1. A wrap of 3, 1, 2, 3 units total, 6, 2. For 4, just continue on over this way. 5, 2 is the point. For 9, here was 4, 5, 6, 7, 8, 9. Oh, 9 brings us over to this point, 0, 2. But also what you notice again is there's symmetry in this figure. So if it's 9 units from this point over here, the starting point over to the point 0, 2, then it'll be another 9 down over here to the point -7, 0. So a wrap of 18 is -7, 0. And still another 9 would bring us right here, 0, -2. A wrap of 30, I'll just know that I went to a wrap of 27, brought me down to 0, -2. So 3 more units, 1, 2, 3, would bring me to the point 3, -2. And a wrap of 500. Well, of course, a wrap of 500 is greater than the perimeter, greater than the period of this problem. And the perimeter would be 9, 18, 27, 36. So we're going to do 500 mod 36 because 36 is the perimeter or the period. So to calculate 500 mod 36, we will divide. What is going on with this thing? Here we go. I see what's happening, folks. We will divide 500 by 36 and get 13.8 repeating. Remember, that means that you would go 13 full periods or 13 full perimeters around. Plus, you'd have 0.8 of a perimeter or a period remaining. So since the full period is 36, 0.8 repeating times the 36 gives you 32. Now on my calculator, what I do is I do 500 divided by 36. I get the 13.8 repeating. I simply subtract 13 and then take that value times 36. So that would give me that this is the same as a wrap of 32. I know that a wrap of 36 brings me all the way back to the beginning, so I actually just have to back out 4 units. 1, 2, 3, 4, bringing me to the point 5, -2. So if you think about it, you could always kind of go backwards in the negative direction or forward and end at the same point. So to get to the same point, if you add a value and you take another value, the negative value, those two, the absolute value of each of those values would be the whole period. So 32 and 4 is the 36. A wrap of -20, again, negative means go in the clockwise direction, so we're going this way. That's 9. Over here is 18, and then 2 more right here, -6, 1. A wrap of 300, well, -300, but still we have to do 300 mod 36. 300 divided by 36 gives me 8.3 repeating. Subtract the 8, leaving you just the 0.3 repeating. Take that value and multiply by 36, giving you 12. So this would be the same as a wrap of -12. So -9 is here. 10, 11, 12, -3, -2. A wrap of 8.55, well, it's not quite 9. So you're coming up here, you go, that's 8. And then 0.55 repeating. So you would just simply be at an x value of 0.45, a y value of 2. What is the domain? Well, the domain of all wrapping functions, the set of n's such that n is an element of the reals. Remember, we don't use x for domain in wrapping functions. We always use n, the length of the number line or the distance that you're going around the object. And the range is a set of ordered pairs. All the output values are ordered pairs. So we say they're the set of x, y, comma, y on the object. And in this case, the x's could be between -7 and +7. The y's could go from -2 to +2. But again, crucial, it's on the object because, for example, a point like over here, 2, 1, that is not an allowable value because it's not a figure on the object. So it wouldn't include every single combination of these x's and y's, just the ones that give you an ordered pair on the object. Thank you very much for watching Wrapping Functions Video 2.